I'd like to introduce Dr. Joanne Williams, who's been a member of the Sea Level Group at the National Oceanography Centre in Liverpool since 2008. She researches sea level, tides, surges, and seeking to improve the understanding of coastal flood risk around the world. So we're staying in the sea, and we're going to have a look at storm surge around the UK with a particular focus on 2022. Over to you.
Hello. Well, it was a lovely introduction from Nefeli there into some of the risks out at sea. Thank you, Brian, for asking about the surge forecast modelling. I can answer that one, which is that currently the operational model is still a 2D model, and it runs on about a 7-kilometre grid. When the next generation of models there's a choice about whether we go to a finer grid and include more wetting and drying as you go up the estuaries, or whether you start moving into a 3D grid and integrating it more with other ocean parameters that you're modelling. Both those models are doing really well in development, but they're not quite ready for operational use just yet. So storm surge, I'm sure many people will be familiar with. This is all about what happens when the wind is building up water in a particular area, or also when the just from atmospheric pressure being low, if the atmospheric pressure is pushing down less on water in a particular area, if it's allowed to rise just from that lack of pressure above it, and so you get a surge due to that. Whereas meanwhile, in high pressure system like we're seeing at the moment, you'll see that the sea level is a little bit lower than you would have predicted just from the astronomical tide. So obviously around the UK we've got some of the biggest astronomical tides in the world, and everything we do when we talk about storm surge, we have to really think about the tide as well, because it doesn't matter really what the weather does, if it's on top of, if the tide's incredibly low at the time, then you won't see the sea anyway in many areas. But obviously if you've got high tides and spring tides as well at the same time, then that becomes very important. We've just had the anniversary of the biggest storm surge in living memory, well not so much biggest, but the most damaging storm surge in living memory in the UK, which was the 1953 surge. In fact, we saw a bigger one in 2013, but the 1953 one, that was very damaging along both the east coast of the UK and in the Netherlands, and that triggered a lot of the modelling and forecasting work on surges and a lot of the protections that have been built. And so now, although we've seen bigger surges since, we've never seen anything as damaging, thanks to those warnings and those flood defences. So I won't be talking about the waves, and of course the waves, whilst they're enormous out at sea, they're also as they break onto the shore, they can do an awful lot of damage as well along the coast, but that's not my expertise, so I'm steering clear of that. So I'm going to be talking about what we refer to as the still water level, the average after you've taken the waves out, average over a few minutes, that level. So sorry, just slides. So if you want to look at surge levels, there's various places you can grab the data, and live data at a number of sites is available through the National Tide and Surge, the Sea Level Facility, so we're part of the forecasting system, but in only in a semi-operational way, in that we take the data that comes out of the gauges, and we take a look at that after the fact, a few weeks down the line, and say, well, how did the forecast do in recent weeks, and how have we got on? So then we are able to feed back to the Met Office and and hence back to the forecast centre ultimately if there have been any issues with forecasting lately. So again, of course, we've got to think about the astronomical primarily tide, and then we talk about surge on top of that. And just a quick orientation for the for slides to come, in that I looking at 40 odd gauges around the coast, and I tend to spread them out, unwrap the coast into a single line around there. So we've got Sheerness at the bottom, up the east coast, and then Scotland, and then round to the west. So when you look at the total water level, everything comes down to the tidal cycle dominates nearly everything in the UK. And so if you just look at total water level over the course of the year, the spring neap cycle is what you really see most of all. So that sometimes you've got very big variation from one day to the next, from 6 hours on to the next 6 hours. And then in the neap tides, you get a very little small variation. 2 weeks later, so it's new moon, you've got full tides. And then the next full moon, you've got another spring tide there. So that variation dominates an awful lot. And so when we look at what the total water levels have been, there were quite a lot of sites in 2022 where the total water level was dominated by just simply from the spring tide. So that's great. That's something that we can predict very easily. In fact, we can produce astronomical predictions for many years into the future or into the past. And we can look at data from the 19th century and we can do astronomical predictions and say, oh yes, that is the data that was recorded 150 years ago. So those are very robust, very long-term predictions that we're able to do. And then of course the weather effects are dependent on the forecasting just a few days ahead. So yes, many places just saw the spring tide in September was the dominant one. Then Storm Eunice dominated on a number of sites on the west coast, and Storm Malek, various sites on the east coast. That's when they saw their highest tides. Storm Malek actually fell on a neap tide, which was incredibly fortunate. So it fell when the tidal range was very small those particular days. If it had fallen on spring tide, we would have seen much higher levels in some of those sites. So when we're looking at trying to get into the data, first thing we need to do is to take that major tidal signal out. And we often talk about non-tidal residual. So we just literally take off the predicted tide, which is mostly a sine wave. And as a result, you get you can see then patterns that occur right across many gauges. So here, for example, this is not one of the named storms, but some event right down at the end of September, first day of October, and you can see that had a ripple all the way through everywhere in England and Wales, pretty much. Not so much in Scotland, just no, not much there. So those events can be right the way through there. And here we see the named storms of the season, and a little bit of storminess in November as well. So highlights here the named storms, and they do pretty much correlate with those biggest events. And then I've picked out a few others as well where there were some surge residuals, but it did work out this year that I'm interested to hear from the Flood Forecasting Centre that they do influence the storm naming as well, and that nothing was named, nothing was missed in the naming in terms of there being very big surges that weren't part of a named storm. So when we look at some specific events, so here Storm Malik and Corrie, very inconvenient of them to be so close together. I was forced to change my plotting system so that I could fit two storms on the same plot, so close in. So each site here around the coast, what I've plotted here is just the difference between the predicted tide and what was actually recorded at the gauge. So you can see that many sites along the east coast have these spike for Malik and then another spike for Corrie. But there's a subtlety about when we use surge residuals, which is it's not very well understood. So I'm sorry if this is a bit technical, but it does come up quite a bit one way or another. So the one thing that the surge does, the tide doesn't go up and down everywhere simultaneously. The tide moves as a wave along the coast. So the tidal height propagates as a wave. And the way a wave propagates in the sea depends on the depth of the sea. So if you've got a storm surge and you've increased the water depth by 1 metre, then that tidal wave will propagate a little bit faster. And so rather than the black line here, the predicted tide that we expected to see, not only is the level a little bit higher, but the peak tends to arrive a little bit earlier because the wave can move faster. So what you get is that the storm surge residual, the difference between what we actually measure on the ground and what we predicted, it is particularly big just before the peak of the tide. And so it's a sort of phase change, which is sort of aliasing into the difference. Now, we don't really mind too much about that. It affects what time you need to close your storm gates, but it doesn't affect in itself the biggest level and the highest level that the observations are going to get to. So another measure we use is called skew surge, and so I'm going to be talking about these skew surges, and that's the difference between the absolute height of what you measured and the height of the predicted tide that was written on the high water levels that you've pinned to your harbour wall. So this peak here of the black line is the number that was forecast 2 years in advance, and the red line is the number that hopefully you forecast a couple of days in advance, and is the number that you've measured, and that difference is the skew surge. And so when we talk about skew surges, it's more robust because it doesn't have this phase change, and we see that they're often not quite as big as the residual, but also sometimes they're bigger than others. So if we look down here, what happens in Cromer during storms Malik and Corrie. In Malik, we had this really big tidal residual and also a really big skew surge. It really was a substantial storm there, and it's very lucky it didn't fall on a larger tidal cycle. The second storm there, Corrie, it's a big residual, but for some reason it didn't have the same effect, or it had more effect on the wave propagation. So the big residual is largely because of the timing being different there, and so the skew surge isn't quite as big, and the actual peak water level therefore isn't quite as big. But this one here, Malik, and I've just been looking up some of the previous biggest events at Cromer, and it's not quite the biggest we've seen, but it's certainly in the top 5 biggest skew surges that we've witnessed in chroma. So I'm just give myself some power, that's better. So storms, Dudley, Eunice, Franklin, 1, 2, 3 straight after each other. They were much more widespread all across the country. And again, you know, surge after surge, both west and east, and particularly on the west coast there, some very large skew surges again of over 1 metre higher than the predicted tide. But again, very fortunate in the timing, because although they did fall on a spring tide, the spring tides are not all the same as each other. The spring tide, that particular event, was about 1 metre smaller than the one just 2 weeks earlier. So fortunately, not so much damage as could have otherwise occurred there. I couldn't resist including Arwen, even though it belongs to 2021, because it was such an unusual event. The west coast on Arwen, it was, I've not seen it on any other event I've looked at like this, in that the water levels were so low, much lower than the forecast tide all along the west coast there. And it'd be really interesting to hear if anybody knows about port operations, whether any ports were severely affected by these low levels, because of course you can run out of water as well as have risks from flooding. Thames barrier closures, again, reasonably calm year, so there weren't so many. So I think it was Corrie and Mallock, and just 4 other events where the Thames barrier was closed, including one on Boxing Day. So not the busiest year for that, which was very fortunate. But where are we going in the future? Well, the sea level is rising. Even with the lowest possible emissions, sea level will carry on rising into the future to some extent through to existing ice melt that will already happen. And obviously how much sea level rises depends on our future choices and our present day choices about emissions and so on. There are some very worrying possible scenarios where you get ice sheet collapse, and so this is a line that follows only an RCP 845 scenario, but with a high risk ice sheet collapse. And so when we look at what those numbers do to surge risk, we're looking at a metre at the by the end of the century, potentially far more. If we stay on this RCP 4.5 line, maybe we're down as little as sort of half a metre, but they're still pretty big numbers. So half a metre or even a metre, when you're looking at a tidal range of 10 metres, doesn't seem terribly dramatic. But it's all about how often you get over a particular storm level. So if some storm, this is a distribution here of how high the storms get, or how high tides get. And so, most events are around this level in the middle here, but you get the occasional event that's up to a certain height. Now, if you change that mean, if you add on a fixed level, then most events are a bit higher, and you've got the level that was previously a very rare line that you would reach now becomes common. You now get many events at that level. And so where it was something that would perhaps happen once every 100 years, you might now be looking at it happening every year, or on average every year. Another way of putting that, we often talk about return periods. So yeah, 1 in 100-year event. That if that's got a particular water level that can be reached 1 in 100 years, then in some of these future scenarios, we could be looking at that becoming an event that happens every single year. And then, of course, how much different is that if we're looking at less severe sea level rise scenarios? So if we look around the country, fairly similar sorts of patterns around most of the UK, but it does depend on the tidal range and how impacted different places are due to surges and due to waves. But yeah, so for the high impact scenario, if you've got that RCP 8.5 and the ice sheet collapse, we could be looking at 100-year change, 100 times change. So something that becomes was a 1 in 100 risk becomes a nearly every year risk of storm. Whereas under the less severe scenario, if we manage to limit emissions to less than the Paris Agreement, so on, we could be looking at perhaps it's about 10 times more frequent. There will be an increase in the frequency of storms, but perhaps to a level that we can handle in terms of our mitigations and our flood defences. So yeah, that's me. And I work at the National Oceanography Centre. I'm based up in Liverpool. Many colleagues down in Southampton as well. And we are currently a charity. Previously, we were more like the Environment Agency, part of government organisation. These days, we're a charity, but we still work in close collaboration with EA and Met Office. Yeah, that's it for now. Thank you.
Brilliant. Perfect. Thanks, Joanne. Really interesting talk and nice to kind of close off, I think, our overview of 2022. We're looking at storm surges. I'm going to take one question and then I'm going to invite the rest of the speakers to join so we can get into more of a general discussion as we close. But I've got one question here from Brian, just asking about, what is the balance between sea level rise and the isostatic land height change when we look at future coastal flood risk?
Yeah, obviously that's so flood risk at any particular place is very locally determined by what the land is doing as well. So in some places, very locally, you can get like sinking due to a city being built and all sorts of things. In the UK, in the past, we'd had this tip sort of correcting after the ice sheet had melted, so that Scotland was still rising up out of the water and the south of the country was sinking. It's no longer the case that anywhere in the UK is rising up out of the water. There are still places in northern Scandinavia which are still rising up after sea level, after the ice sheet melt, but everywhere else pretty much is dominated by sea level rise. Sea level rise is now faster than the ice sheet correction, and then of course there are places that, due to that tipping of the land, it adds to it and makes it faster still. So.
Great. Okay, can I just get you to stop sharing your screen at the end? Can I invite the other speakers to put their cameras on, and we'll move into the kind of final session, which is taking general questions from delegates. There's a couple of questions that I guess have come up that are kind of linked, so I'm going to start with that. So Norman asked earlier about the impact on climate change on things like the jet stream and the likelihood that a change in the jet stream might lead to either periods of more prolonged blocking or an increase in the storm, depending on what happens with the jet stream. And Edmund kind of touched on that as well about, what's the predictability of frequency of storms and the impact it's going to have, as Joanne's been talking on, say, storm surges, as we look into kind of future projections. So does anybody want to comment on the kind of current position of where we think climate, the impact, I guess, on jet streams and storms around the UK? What's the current thinking generally? Anybody want to pick up on that?
Well, I thought I would like to see, it's been mentioned that we're forecast to have wetter winters and drier summers, and we have indeed been moving into wetter winters over the past few decades, but the drier summers, I think, is less certain because of, for example, feedbacks from declining Arctic sea ice and that sort of thing, because between 2007 and 2012, we had a run of summers with high pressure over Greenland and low pressure systems actually moving further south and giving us wetter summers.
Yeah, absolutely. And as you say, the future projections are looking at hotter, drier summers. And if you look back over recent decades, when we haven't seen many of those, 2022 probably is a warning sign of potentially what could come if you look at future projections. But yeah, any other thoughts about the impact on the jet stream? And just generally, I get the feeling the jury's out. There doesn't seem to be a huge amount of certainty out there in the science about the impact on the jet stream as to whether it's going to weaken significantly and we're going to see more blocking systems, or whether it's going to become more active, or whether it's going to move its position. Any other thoughts from the panel?
It's difficult, like what Ian's saying, and oh, sorry, Brian. Yeah, I think it's uncertain. I know in terms of heat waves, I've seen a projection that shows that there's likely to be an increase in high pressure blocking over Europe, and that was kind of like a ensemble projection from like a German institute. But I think with all of these things, it's very difficult to be certain, but also we've seen these extremes in terms of flooding and in terms of heat waves and drought, that we know that we need to be prepared. So we just kind of need to do that now, instead of just being completely certain of like, in 10 years on this day we will have a heat wave sort of thing, I think.
So let's move on then. I mean, as you say, we're seeing our climate change here in the UK. We've had lots of examples of that in 2022 with various record events, whether that's temperature or rainfall, flooding, sea level rise, for example. It'd be just interesting just to kind of think about resilience. So there was a question from Robert about the effect if we did reforestation or rewilding. What's the impact that would have on flooding, both from a mitigation but also from an adaptation perspective. If we green our cities to provide kind of natural air conditioning and look at a way of kind of adapting within the cities to deal with heat. Each of you, I guess, come at it from a very different perspective, whether it's temperature or flooding or sea level rise. But what do we need to start thinking about to become much more resilient to these extreme events? Anyone want to start with? Well, yeah, Brian.
You may have heard of slowing the flow, which is one of the things that we're trying to do. So in upland catchments, planting deliberately to slow down the infiltration rate of these rivers upstream is something that we want to slow it down. So you can imagine the hydrograph kind of taking the peak off the hydrograph away. So it's certainly something that we're doing in the Environment Agency. On climate change as well, with flood defences, we are definitely planning for that climate emergency. So you may have heard of the next Thames barrier and all the defences along the tidal Thames, certainly taking that into effect. And of course, in urban, a lot of things, simple things like people's front gardens disappearing into driveways, things like that, really affect. It's that kind of, it's the ripple effect of not one person will too much effect. If you get 50,000 people in the town, all concreting over their gardens, you're looking at the sustainable roots going through the roof with all these things. So certainly something that we're working with planning authorities as well for this as well.
Chloe, any thought from heat perspective?
I mean, so urban greening is really great. I think similarly to what Brian said, that would also be very good for heat waves, because if you have greening in urban areas, it reduces the heat in the surroundings. I think that I always say that heat is a long way behind flooding, and so I think there needs to be more done in the UK on that. And also, I'd quite like to see it linked up with something like the Flood Forecast Centre or National Oceanography Centre, because they're all affecting us in terms of climate change. And I think that forecasting, good infrastructure, urban greening, nature-based solutions are all things that benefit all of us, I think.
Yeah, different benefits. And Joanne, you're one of your last slides, you showed the Thames Barrier and how often it's been closed this year. You know, I guess the future of something like that, these kind of coastal flood defences and barriers like this, you know, thinking just future resilience. I mean, you know, the long-term future of something like the Thames Barrier. Any thoughts on that?
Yeah, I mean, as I understand it, the Thames Barrier, they think will last long enough that they don't need to start building a new one just yet. But obviously, you know, in the 100 years time scale, we will need to be improving those defences there. But you can't build a wall around the whole country, so you need to start using more imaginative protections in different places. There's been some interesting work on things like improving salt marshes out to sea, to, you know, so that although they won't stop the absolute water level, they might reduce the wave impacts that come on top of the water level and things like that as well. But I think really it's about long-term planning as well, about, you know, when we've got lots of warning on this. So we need to be looking into the, you know, at a planning and development level about, you know, where do we want to be building? How do we reinforce our infrastructure? You know, do we making sure that roads are going to be still in a good place in 100 years time, not just in 10 years time, and drainage and so on. So it's long-term planning that this needs to go into.
Right. So we've had a fantastic overview of 2022, and as we kind of move forward into 2023, I guess it'd be good to just think about some of the major things that are potentially coming our way. And Stephen, I think, can we start with you, just thinking, you know, having come off the back of 2022 and, you know, the lack of rainfall, even though we saw some, you know, some replenishment towards the end of the year, we're certainly going into 2023 with, I guess, some nervousness as we approach spring and summer.
Yeah, definitely. And as Brian mentioned, and we saw, there's still some areas in the UK, in England, sorry, which are still in drought status now in the southwest and East Anglia. So obviously that suggests that we're coming into 2023 at a deficit in some places, and we're really relying on higher rainfall, higher than average rainfall over 2023, so that we have a resilience during that summer period when water supply usage goes up, it gets hotter. We'd like to see sort of that rainfall going in to the summer. It's hard to say that the current 3-month outlook for precipitation is looking to the sort of normal to below normal side. So I not going to try and predict the future, but I wouldn't be surprised if we started seeing like more water saving messages from our water companies. But I know the National Drought Group, which is made up of the Environment Agency and the water companies, are regularly meeting to mitigate against any potential impacts that the public might see. And I guess they'll be meeting regularly as the months go on through the spring, and we see how much rainfall we receive in the spring, because that rainfall we do receive over winter and spring does have an impact on our water resources. But as we move into summer, due to the higher temperatures, more evaporation in the summer, any rainfall we do get in the summer does have less of an effect on our water resources. So yeah.
Great. And I guess if we focus on temperature, maybe come to Chloe again, but, you know, if we're moving into an El Nino, you know, concerns of the kind of temperatures that we could see, you know, globally, but maybe even here in the UK as we go through the rest of 2023.
I saw a report in the beginning of the year saying that if we move into an El Nino, 2023 could be even hotter than 2022, but there's think quite a lot of uncertainty around that. Usually we can tell kind of the average trend of the summer in about May in the seasonal forecast. So I would not be confident to say anything on the trends for this summer just yet, even if we'd already moved into an El Nino. But yeah, I think is very important, especially if we continue to have a drought trend in the spring. That also could have a massive impact.
Yeah. Brilliant. Okay, I'm going to just say a big thank you to all our speakers this afternoon, Ian, Chloe, Stephen, Brian, Nefeli and Joanne. Thank you very much for taking time out on a Saturday afternoon. It's been a really interesting, and I think, climate change is very evident in this country, as we've seen just looking at the year 2022. So I think we've got a couple of slides as I close off. I'm hoping Catherine can put the slides up for me. Great, thank you. So just to say thank you very much and keep in touch. We'll be sending a survey out just to find out what you thought about the event. It's something we run annually, so any feedback is really welcome, just to kind of improve these events as we go forward. And then just also to mention a couple of events that you may be interested in that are coming up on the next slide. So if we can move on to the next slide. Thank you. So we have an event at the Geological Society in London next month on the 15th of March, and this is about space weather, so the impact of solar flares, and for example, that has an impact on our energy sector. And then in April in Edinburgh, taking place at Dynamic Earth, and also an opportunity to walk up Arthur's Seat as well, we've got our mountain meteorology looking at climate change and forecasting perspectives. So 2 face-to-face events coming up in March and April. If you're interested to find out more, you can go onto the Society's website and register for either of these events. But I'd just like to say a big thank you again to our speakers and everybody who's joined this afternoon. I think it's been a fascinating few hours, and wish you well. Bye for now.